Hello friends, welcome to Ecet video classes. In the last episode, we have discussed the tangents and normals in application of derivatives. The next topic under application of derivatives is tangents and normals completed. Next one is maxima and minima. Now we have a function y is equal to f of x. That means a single variable functions only we will discuss in this syllabus. Okay, so y is equal to f of x is a given function. Then to find out the increasing interval, decreasing interval, next stationary values, next finding maxima, finding minima values, some standard forms like a cos x plus b sin x plus c and ax square plus bx plus c. These main points we will discuss in this chapter. Now let us come to maxima and minima. Here first given y is equal to f of x function. This is a single variable function. This is given function y is equal to f of x. Now the first point is to find the increasing interval. To find the increasing interval of the function f of x, find the values of x such that f dash of x is greater than 0. We have to find out the values of x such that f dash of x is greater than 0. What is f of x? F of x is the given function. I will be taking a small example. Here the example is x square minus 5x plus 6. This is the function x square minus 5x plus 6. To know the increasing interval, you treat this given function as f of x. Now f of x is equal to, let f of x is equal to x square minus 5x plus 6. Find out f dash of x, that is 2x minus 5. This is the derivation. Now for increasing interval, for increasing implies f dash of x greater than 0. That means 2x minus 5 is greater than 0. Now we want to find out the value of x satisfying the inequality 2x minus 5 greater than 0. That is x greater than 5 by 2. 5 by 2. Now you can imagine this is a real line and this is 5 by 2. More than 5 by 2 means up to infinity. Therefore the interval is 5 by 2 comma infinity. So in this interval the function is increasing. Now the second point is to find the decreasing interval of f of x. Find the values of x such that f dash x is less than 0. So I'll be taking a small example, the same example what we have taken in the previous, x square minus 5x plus 6. Now I'll be finding the decreasing interval. For that f dash of x is less than 0. Now what is f dash of x? It is 2x minus 5. So 2x minus 5 is less than 0. For this x square minus 5x plus 6, f of x is x square minus 5x plus 6 and f dash of x is equal to 2x minus 5. F dash x less than 0, that implies 2x minus 5 less than 0. This is x less than 5 by 2. For less than 5 by 2 values, this function is decreasing. Observe this in real line. Less than 5 by 2 means up to minus infinity. Therefore, you can write the interval as interval is equal to minus infinity comma 5 by 2. Observe here In both the cases, for increasing or decreasing, we are not including this 5 by 2. We are not writing greater or equal to. Only strictly greater than 5 by 2. Here is strictly less than 5 by 2. Now put a question. What about for x is equal to 5 by 2? Then the function becomes 0. F dash of x, 2 into x is equal to 5 by 2, 2 to cancel, 5 minus 5 becomes 0. That means f dash of x is equal to 0. This is the third case. We call it as stationary values. Third point is stationary values of f of x. To find out the stationary values of a given function f of x, f dash x is equal to 0. Now f dash of x is equal to 0, x values. You consider the x values such that f dash of x is equal to 0. That means 2x minus 5 is equal to 0. This is taken previous example. So 2x minus 5 is equal to 0. Then x is equal to 5 by 2. So that means at x is equal to 5 by 2, f dash x becomes 0. That means x is equal to 5 by 2. This is called stationary value. This is called stationary value. Now remember, to find out the increasing interval of a given function f of x, find f dash of x and it is greater than 0. You resolve into factors, then find out x value. Similarly, for decreasing, f dash of x is less than 0. Resolve into factors, find out x value. You get some interval. And for stationary values of the given function, f dash x equate to 0. Find out x values. You may get 2 values or 3 values or single values. Depends on the degree of the function given. Right? Now, increasing, decreasing and stationary values. Next. Because of lack of time, we are not discussing geometrically in detail. Okay, briefly, already you have studied these topics. So briefly I am explaining the points. So decreasing interval, increasing interval, and next stationary values. Next, a function is given to find out the maximum or minimum values. What is the working procedure, working rule, that we will discuss here. So now maxima and minima of the function f of x. Maxima and minima values of the function f of x. First, this is given f of x. If directly a function is given, you call it as f of x. That is, f of x is equal to some polynomial, trigonometric function, whatever it is. Now this is given f of x. Now the second one, find the values of x such that f dash x is equal to 0. Next, you find out the derivation and then equate the derivation to 0. You get x values, maybe 1, 2, 3 or maybe any number of values. Now this is f dash of x is equal to 0. So in this case we get the stationary points. Suppose if we get x is equal to some a1, a2, 2 values I said. Then the third one is find f double dash of x at x is equal to a1. So find the second derivation and the second derivation value at x is equal to a1. So you may get the negative or positive only. F double dash of x, if f double dash of x at x is equal to a1 is negative. If you get a negative value, then the function has maximum. Then fx has maximum, then fx has maximum value. That maximum value is function of a1. So at this point a1, the second derivation is negative, therefore you substitute that a1 in the given function, you get maximum value, right? Next, the fourth point is find f double dash of x at x is equal to a2. So at x is equal to second point. So if f double dash of x at x is equal to a2 is positive, if you get a positive, then fx has minimum value. Minimum value. What is that minimum value? Minimum value is f of a2. So substitute a2 in the given function, you get minimum value. Observe here, negative you get maximum. When it is positive, you have minimum value. Suppose greater than 0, it is neither greater than 0 nor less than 0, sometimes is equal to 0 you get. So at that case, neither maxima nor minima, but we'll have the problems only finding maxima, finding minima only. So that is why we are not discussing such a type of points. Okay, so this is maximum, minimum. This is the working procedure. Given function f of x, find out stationary values, that is f dash x is equal to 0, you get x some values. At each value you find out f double dash of x. If it is negative, decide you have maximum, and if it is positive, decide it is having minimum value. But in problems, find maxima or find minima for this function, like that type of questions will come only. So no need to check negativity and positivity, all these things. At directly, if you get x different values more than 1, then it is needed to check whether it is a positive or negative. Otherwise, if you get a single value, directly you substitute that point, then you get the maximum or minimum. Okay, now we have two standard forms for this. Standard forms. Now, the minima and maxima of a cos x plus b sin x plus c is c minus root a square plus b square, c plus root a square plus b square. So directly, when a given function is in the form a cos x plus b sin x plus c, you have c minus root a square plus b square is minimum and c plus root a square plus b square is maximum. Observe here, compare the given function with this form only. Cos x coefficient a, sin x coefficient b, and the constant term is c. Then this is also called range of the given function a cos x plus b sin x plus c. Okay, this is range. Next, another second form. If f of x is equal to ax square plus bx plus c, like a quadratic function is given ax square plus bx plus c, there are two cases. If a less than 0, if this is x square coefficient, if it is negative, you have maximum. This implies fx has maximum. So this function is having maximum value when x square leading term coefficient is less than 0. Now at which point it is maximum and what is the maximum value? At x is equal to minus b by 2a, the maximum value is equal to 4ac minus b square by 4a. This is your maximum value. Okay, this is maximum value. Next, minimum value. if a greater than 0, if a greater than 0, that implies fx has minimum value at x is equal to minus b by 2a, and the minimum value is equal to 4ac minus b square by 4a. The formula for maxima and minima is same, but when it is having maximum, when it is having minimum, that depends on the x square coefficient sign. A less than 0 maximum, a greater than 0 minimum. So only remember, this type of quadratic expression is given directly. You see a sign, then you can decide whether it is having maxima or minima. Suppose x square minus 5x plus 6, then x square coefficient is 1, it is a positive means it is having minimum value, and you can find the minimum value by putting this formula 4ac minus b square by 4a, and substitute abc values in this, you get directly minimum value, or if a is less than 0, you get the maximum value. So these are about the maximum value, minimum value. So what are the points we have discussed here? Increasing function, decreasing function, increasing interval, decreasing interval, and stationary values. Next, given a function f of x, to find out maximum or minimum values, we have discussed the working procedure. After that, there are two standard forms have seen: a cos x plus b sin x plus c, and next one quadratic form ax square plus bx plus c. Okay, so I observed all the papers of your Ecet and have seen maximum the problems based on these points only. Okay, now we will discuss the problems. Now in the first problem, he is asking the interval in which the function is increasing. So first problem, the interval in which x cube minus 6x square minus 36x plus 7 is increasing. He is asking increasing interval. Now, according to the procedure, call it as f of x, x cube minus 6x square minus 36x plus 7. Find f dash of x. This is 3x square minus 12x minus 36. F dash x greater than 0, that implies 3x square minus 12x minus 36 greater than 0. Now, you can take 3 common, then x square minus 3 fourths 3 12s greater than 0. Now, there are two factors in this. Either this is greater than 0 or this is greater than 0. That means the product is greater than 0. You know that 3 is greater than 0. So, only bother about this expression. X square minus 4x minus 12 must be greater than 0. Now, minus 12 factors are 6 to the 12 minus plus, then this is minus 4 and this is minus 12. Now, first writing the factors. So, this is x. First write the plus term and next minus term, which is greater than 0. This you can express in the form x minus half minus 2, x minus 6 greater than 0. Now, in the theory of equations or in quadratic equations, you have if x minus alpha into x minus beta greater than 0, that implies x less than alpha or x greater than beta. This is the formula is there. When two factors x minus alpha and x minus beta product is greater than 0, then alpha is the smallest, beta is the largest value, then x less than alpha or x greater than beta. Now, about alpha is equal to minus 2, here alpha is equal to minus 2 and beta is equal to 6. Okay, this is alpha and this is beta. Therefore, the interval or x less than minus 2 or x greater than 6. X less than minus 2 means what? minus infinity to minus 2, all the values are less than minus 2 only. Therefore, x belongs to minus infinity to minus 2, and here x greater than 6 means 6 to infinity. So this is 6 to infinity. Therefore, the complete interval is union, right? Here is minus 2 here, 6 is here, less than minus 2 up to minus infinity this is, and this is up to plus infinity. So it is less than minus 2, greater than 6 means it lies in the union of these two intervals. Okay. Now in these intervals the function is increasing. That means f dash of x is greater than 0. You can take the values between minus infinity to minus 2 by taking any sample value and then substitute there whether it is satisfying the inequality or not. That you can check. Okay. This is about the increasing. Next, the second problem. The values of x. The values of x when x cube minus 3x square plus 6 is decreasing. So for decreasing and increasing, call it as f of x, x cube minus 3x square plus 6. F dash of x is equal to 3x square minus 6x, x square derivation 2x, right? F dash x less than 0 for decreasing. This is f dash x. 3x I can take common. This is x minus 2 minus 6x. This is 3x square, which is less than 0. Now 3 is not less than 0, so leave that numerical value. Then x means it is nothing but x minus 0 and x minus 2 less than 0. So here is one formula, x minus alpha into x minus beta less than 0 implies alpha less than x less than beta. That means x value is lying between alpha and beta. Therefore, alpha is the smallest and beta is the largest. Therefore, the interval is 0, 2. So, 0, 2 is the answer. In this interval, the function is decreasing. So, increasing problem and decreasing problem. Then, we'll go to the next problem. The third problem is the maximum value of the function, maximum value of the function y is equal to 2x cube minus 6x square minus 18x plus 21. Now about maximum value, therefore call it as f of x. 2x cube minus 6x square minus 18x plus 21. According to the theory we have discussed, find out f dash of x is equal to 0 values. That means stationary values. It is 3x square into 2, 6x square minus 12x minus 18. F dash x equate to 0. That means dividing by 6 directly, it is x square minus 6 2 is 12, 6 3 is 0. So here minus 3 factors, 3 1s 3, minus and plus, here is minus 3 plus 1. Therefore, 1 is x is equal to or x plus 1 into x minus 3 is equal to 0. That means x is equal to minus 1 and x is equal to 3. As in theory we have discussed a1 comma a2 two values. Then we have to find out f double dash of x at x is equal to minus 1 and at x is equal to 3. But we want only maximum. Maximum means what? F double dash of x must be less than 0. Now finding f double dash of x. F double dash of x is equal to f double dash of x. This is 12x minus 12. Now f double dash of x at x is equal to minus 1. that is equal to 12 into minus 1 minus 12. This is minus 12 minus 12 minus 24, which is less than 0. Whenever f double dash of x is less than 0, you get to maximum value. That means what? You want maximum value only. So maximum value only, f double dash of x less than 0 at x is equal to minus 1. Therefore maximum value is f of minus 1. This x value put in the function x is equal to minus 1. Then it is 2 into minus 1 whole cube minus 6 into minus 1 whole square minus 18 into minus 1 plus 21. Now this is equal to, this is minus 2 minus 6 plus 18 plus 21. Anyway, this is 18 minus 8 is 10. 10 plus 21 is 31. This is your maximum value of the function f of x. Okay. Now maximum value, increasing, decreasing, maximum. Next, the fourth one is the minimum value of fx is equal to 2x square plus 3x plus 1 is dash. So f dash of x, it is 4x plus 3. F dash x is equal to 0 implies x is equal to minus 3 by 4. Only single value minus 3 by 4. So you want the minimum value of the function is dash. Minimum value of the function fx is dash. Now f double dash of x is equal to, now 4, this is 4, anyway positive. Positive means the function is having, f is having minimum because it is greater than 0. So this is having minimum value. The minimum value substitute in the function f of minus 3 by 4 is equal to 2 into minus 3 by 4 whole square plus 3 into minus 3 by 4 plus 1. I got only x value minus 3 by 4. Now this is 9 by 16. So 9 by 16, 2 8 is 16. Minus 9 by 4 plus 1. Now 8 for LCM is 8. So first one is 9. 4 2s, 2 9s are 18. Plus 8 1s are 8. Okay. 17 minus 18 is minus 1 by 8. This is your minimum value of the function. Okay. Increasing interval, decreasing interval, maximum and minimum. So in these 4 we have discussed polynomial functions. Maybe third order or second order, whatever the order. Okay. Now he is asking in the fifth one, the function fx is equal to x into e to the power of minus x, where x belongs to R, attains a maximum value at x is equal to dash. He is not asking the maximum value. He is asking at which point the function is having maximum value. Right? Now, f of x is equal to x into e to the power of minus x. F dash of x is equal to u into v dash plus v into u dash, directly equate to 0. That implies e power minus x is common, 1 minus x is equal to 0. This e power minus x will never becomes 0. Therefore, e power minus x which is not equal to 0, 1 minus x is equal to 0 implies x is equal to 1. So, at which point the function is having maximum means we got only one pointer. Therefore, at x is equal to 1. This is your answer. No need to find out maxima value. Okay, only find out x value. The next problem, sixth one, the maximum value of x power minus x is dash. He is asking maximum value in this problem. Now, fx is equal to x to the power of minus x, right? Fx is nothing but y, so this is also called y. Now, whenever exponential function is there, you apply log on both sides. So, log y is equal to minus x log x, because a power b log a. Its derivation is 1 by y dy by dx. Remember, dy by dx is nothing but f dash of x is equal to u into v dash plus log x into minus x derivation is minus 1. Here x cancel. This is equal to minus 1 minus log x minus of 1 plus log x. Y sending this side, this is what dy by dx. But according to the procedure, f dash of x is equal to 0. That means dy by dx is equal to 0. That implies this y is nothing but x to the power of minus x. This will not be 0. So 1 plus log x becomes 0. 1 plus log x is equal to 0 implies log x is equal to minus 1. Log x means to base e. Therefore, x value is equal to e to the power of minus 1. This is nothing but 1 by e. So, we got only a single value for x. Then, he is asking maximum value. So, put x value in the given function. So, f of x is equal to, x means 1 by e whole to the power of minus, this is 1 by e. If you want to remove the minus sign, then take the reciprocal here, e to the power of 1 by e. I will be taking reciprocal, then remove the sign negative, then e power 1 by e. This is your maximum value of the function. Okay, the next problem. Next, the seventh one, the maximum value of log x by x. Same, log x by x. Fx is equal to log x by x. F dash of x is equal to u by v. V into u dash minus u into v dash by v square is x square. F dash of x is equal to 0 implies this x cancel, 1 minus log x by x square is equal to 0, then cross multiplication becomes 0. Therefore, log x is equal to 1. That means x is equal to e to the power of 1 or x is equal to e. Right? Now, we want the maximum value. Therefore, substitute in the function x is equal to e. X is equal to e. When you substitute x is equal to e in the function, log e by e. Therefore, it is maximum value is equal to log e by e. Log e to base e is 1. So, 1 by e is the answer. Okay. Next, the minimum value, the eighth problem, the minimum value of 3 sin x plus 4 cos x plus 5 is dash. I told you compare with the standard form a cos x plus b sin x plus c. So that means cos x coefficient is a, b is equal to 3, c is equal to 5. What is minimum value? C minus root of a square plus b square. That is, c means 5 minus root a square plus b square. 5 minus 16 plus 9, 25. Root 25 is 5. So 5 minus 5 is equal to 0. Okay. So thank you for watching. I have completed the Maxima and Minima chapter. I covered all the models. Okay. Thank you for watching.